Okay, hello everyone. Today I would like to introduce the paper Text-to-Image Diffusion Models Methods for Controllable Image Dataset Generation, which was written by me and my colleagues Valeria Efimova and Sergey Muravyov. I'd like to start with this slide. As you can see, there is two images of churches, but I think it's very hard to get it in one glance, which image is real and which one is generated. So as you can see, the image on the left is made by human and the image on the right is made by Stable Diffusion. So as you can see, the generated image is pretty photorealistic and very accurate in representing as a text prompt. So, and okay, this is the one point, and the other is that we have some existing problem. There is a lot of specific computer vision tasks for which it is difficult to obtain a large label dataset. For example, 60 pose estimation, 3D face reconstruction, medical applications, and etc. So we have two questions here. First one is, what if there was a way to fine-tune diffusion model for a desired scenario to apply this photorealistic generalized model to some other scenarios? And what if we could at the same time use a condition for a diffusion model, something could use the condition for a diffusion model something else with a text prompt? What we like to do is to develop a framework based on diffusion model, which could leverage generalization abilities acquired from training on large data set for generation of labeled images with our objects of interest. What could be objects of interest? For example, it can be your cat, dog, or favorite race. And labels can be anything, 3D pose of some object, imitation mask, or face landmarks, and etc. At first, let's begin with existing solutions for synthetic labeled image data generation. So the easiest thing we can do is just to project 2D target, 2D image of target object on 2D background. In this case, we can easily make labels for this image because we know the position of target object. And the same thing with projection of 3D image on 2D background. So yes, 3D object on 2D background, yes. So as we know the position of the 3D object, we easily can make labels for it. Yes. But yeah, there is a problem that this images probably won't be so photorealistic even after image harmonization. This is one problem, and the other problem is that even if there will be photorealistic, it is very hard to find a place to on image to project our object. Or there can be no space for it. Yes, so there's two problems with this method. The other one is that we can use virtual 3D environments to place our target object and generate labels. It is very easy to do because we have a lot of control with scene. So, but there is problems like it is very expensive to build such scenes in Blender, for example, or other software, and yes, it is very expensive because if we need a lot of different environments for our objects, it is very consuming. And another thing what we can do, we can use GANs, generational networks, yes. So the generation adversarial networks. And what we can do, we can use GAN to generate some image and some label generator to generate labels. Yes, as it was proposed in some papers. For example, there is image from paper Hands Off. So yes, but there is problems with that GAN. Not so less propose less diversion compared to diffusion models usually. And the other one is that in the paper that was analyzed, there was no solution to put target object on image. So yes. So what we can do with diffusion models? What solutions for diffusion models exist? So we can fine-tune diffusion model with two methods. So there is a textual inversion algorithm, for example, where we just fine-tune model for with just token. We just use tokenizer and create new tokenizer, in-text tokenizer, and fine-tune new token to so this token. So after we put this token in our model, it will the image will have our object of interest on image. Yes. So this is one solution, and this is the results of the solution, which was shown in the corresponding paper. As you can see, the image is pretty similar to the original one. Yes, and the other solution is Dreambooth, where we fine-tune UNet. Yes, we fine-tune UNet to for our class. We create we take some rare token for our object of interest, which is already exist in diffusion model, and train our model to recreate our object of interest. But at the same time, we use class-specific prior preservation laws, so the model doesn't forget about general is a generalization for other objects. Yes. And this is the example of what Dreambooth what can do stable diffusion after Dreambooth method, and there is comparison with textual inversion. So in the column is each column represents different prompts. The first prompt is always in the snow, for example, and as you can see, the Dreambooth methods are more accurate with the target object and more accurate about the prompt. Yes, in different cases, actually. So yes. Okay, these were methods for fine-tuning diffusion models, and this is one, and this one is for control diffusion model. This is a control net. The idea of control net is to take a diffusion model and lock the original weights of the model and copy encoder blocks and put it together with zero convolutions, which is 0 in first iteration. So we will get on the first iteration output from the model as if it will be just stable diffusion, but then it will be trained. Yes. What this control net is about is that we use a text prompt for our original stable diffusion and some condition for control net. Now it is usually images. There is only images as it was seen. Yes, and it can be different conditions. We can train control net for open pose k points. So then our stable diffusion would be able to generate such images with input k points, or it can be a segmentation map, and model will be able to generate images that are correct to correspond to segmentation map, and it can be actually a lot of different conditions if we train control net to process it. So our experiments. For experiments, a plastic container is taken as an example of an object that we want to generate images with. To apply text inversion or Dreambooth method, we use a dataset of 25 rendered images of the bin from 5 different scenes in various poses and light conditions. For fine-tuning with textual inversion, we use parameters which you can see on the screen, and for Dreambooth, we use Dreambooth with LoRa because we don't have a lot of computational resources, so we use LoRa as some approximation of Dreambooth with these parameters, what you can see on the screen. This is example of renders from each of 5 scenes. You can see on the image. We, as it was said, as they were generated in Blender, but it is not necessarily to generate something in Blender. You can just make photo of target object. We just generated it. So yes, the final dataset contains 25 images. And this is the result of our experiments for textual inversion and Dreambooth. There is 5 different prompts, and the first row is the results for textual inversion, and the second row is results for Dreambooth. And as you can see, as in the Dreambooth paper, it is seen that the results for Dreambooth is more accurate for object representation and more accurate for scene representation. Yes. Okay, we now can generate our target object. Now we want to generate images that will correspond to some labels. So to generate images with specific label, we use control net method. For our experiments, we use pre-trained control net subnetwork, which use segmentation image as an input and force diffusion model to generate images that corresponds to a given segmentation image. Segmentation images are rendered from special scene where we place a 3D cube that is the same size as the bin from the previous experiments on 2D background. Then we provide each segmentation image as an input to the control net subnetwork with desirable text prompt. So there you can see the results. There is a prompt on top of that. And from the left, it is input segmentation map. And on the right, it is generated image. So as you can see, as generated image is pretty close to the segmentation mask. So we have actually generated labeled image, labeled with segmentation. So yes, and the same on the right. So conclusion, we built a framework for labeled image generation with target object using recent works such as Dreambooth and ControlNet. Generated target objects is pretty similar to the source, but there is more work to be done. Generated images are close to the segmentation conditions. However, other conditions should be tested and added. For example, object 3D bounding box. So future work is first is to train ControlNet for other conditions, maybe text conditions as well, because there is some limitations with just text prompt in original stable diffusion, for example, or just diffusion models, because there are some problems with numeric conditions when we want to generate 3 or 4 objects. So we maybe want to some more accurate control with text prompt, specific text prompt. Replace stable diffusion with other diffusion models. For example, recently they released Kandinsky 2.1. Improve image generation stability and find a way for detection of incorrect generated image samples. This is important because there is a lot of generated samples that is not so good, and we want to find a way to throw them away and find a way to make generation more stable, because there is a lot of cases when the target bin is not generated with correct sizes, with correct proportions, and we want to fix it. And finally, want to do quantitative comparison with previous existed techniques. So yes, that's all. Thank you. I would be glad to hear your questions.
So, Leon, thank you. Unfortunately, we have time just for one question, a single. So, please, any questions?
Thank you for your talk. You've said about the future research plans, and as far as I understood, you've used several methods out of the box, like Dreambooth, like textual inversion, ControlNet, and so on. Have you maybe provided something new to these methods, some, I don't know, novelty, or you just stacked them together?
So in this report, yes, we just take these methods and stack them. We yes, currently we just stack them, but in future we want. It's not like final work. It's something what we have now, but we want to fine-tune model, control net model for 3D bounding box. It is our target. We need it for. We also need it for some other projects with plastic bins. We want to have an ability to place a bin in different position, 3D position on image, and have labels, have these labels. So we can use it to train some other models. And the other idea is that we want to replace in ControlNet image condition with text condition. Try to do this. Yes.
Thank you.